Hello, welcome to the podcast How We Build, talks about civil engineering in a different way. Hello, today I have Mark Enzer as a guest with me. Mark is the Royal Academy of Engineering visiting professor in the digitalization of the built environment at the University of Cambridge. He is also visiting professor in the Department of Civil and Environmental Engineering at Imperial College London. As strategic advisor at Mott MacDonald, Mark provides advice to key clients on digitalization and broader industry transformation. Previously, Mark was the CTO of Mott MacDonald and the director of the Centre for Digital Build Britain, where he was the head of the National Digital Twin Programme. Mark is a keen champion of outcomes-focused systems thinking, collaborative delivery models, digitalization, connected digital twins, and the circular economy in the built environment. Hi, Mark, welcome.
Thank you.
The start of our conversation is about systems thinking. What systems thinking is and how it fits within the built environment.
Yes, and we can go very deep into that, can't we? And hopefully we will kind of dig into it a lot more. But I think if we're going to kind of just start with a very simple high-level view of it, I think what it's about really is recognizing that the whole is more than the sum of the parts, and seeing the value of the whole of the built environment, seeing the connections and seeing what we can do to get better outcomes for people and nature.
With that in mind, if we are keeping the context of systems in the built environment, where systems thinking is taking us?
Well, I think where it takes us is to a place where we see the built environment differently. Because I think at the moment, one of the ways that we seem to see it, and I'm being very general here, obviously, different people see it in different ways, but in general, I think we tend to see the built environment as a series of construction projects. That's kind of how the industry sees it. But it's more than that because we've been building the built environment for years. And so that means that we've got a lot of it already. And I think it's very helpful for us to see the built environment more as a whole, as a system of systems, and then to see what its purpose is. And I would argue that the purpose of the built environment is to enable people and nature to flourish together for generations. And that's very different from just building new things. Now, clearly, building new things is very important when we need them, but we don't always need them. Sometimes we can get more from what we've already got. And so I think it's incredibly important for us to see that big picture of the built environment with a purpose. And then that means that the things that we build or we modify or we demolish or take away or recycle or whatever, whatever we do in the built environment is in this bigger context of purpose.
So when you say how we see built environment, what do you mean by we or us? Who that would be?
Yes. So it is very broad, isn't it? Because that we encompasses lots of people. I would say, in general terms, the we is all of those who are involved in one way or the other in serving the built environment. And that can be all the way through from policymakers through to regulators, client organizations, contractors, consultants, all of this huge, great big ecosystem of organizations that one way or other serves the built environment. And sometimes we see ourselves kind of in an individualistic kind of way, and we see ourselves through the lens of projects delivering new things, because that's how the industry and how the ecosystem normally comes together. But that same ecosystem can serve the built environment in all sorts of other ways. And so I think one of the things that systems thinking gives us is a systems-based view of the built environment rather than a project-based view of the built environment. And that's easy to say, and built into it is actually quite a lot of difference. But when it comes to who the we is, which is your question, I think the we involves all of us, because in so many ways we have to work together in order to get better outcomes from the built environment.
In that context, when we're discussing we and this difference in seeing our surroundings and everyday life, I would say, not as the series of individual projects, but as the built environment, as the overall system which is interconnected. So what that would mean for everyday life for one engineer who is, for example, working for a contractor?
Yes, it is a great question, and I think probably this would be a good time to explore the connection between projects and delivering new things and the rest of the built environment, because I think that civil engineers working in a project will have a task to do, and they will do their very best on that task on that project. And I think that in that context, we can see the value of systems thinking. I think that systems thinking has value to bring even within the context of an individual project. I think we have even more value to bring outside of the context of individual projects when you look across the whole thing. So if we can just dig into that a bit, and I'll try and explain what I mean. Yes. So if we're looking for a moment just in the context of a project, an individual project, where I think we can bring value from systems thinking in that context is in recognizing that the project isn't just about taking a problem, breaking it into pieces, you're dividing it up into doable chunks, maybe procuring individual organizations to undertake each of those chunks, and then kind of ticking the box of all of those parts of the project, because that is kind of what we generally start by doing. Take a problem, break it into chunks, tick the boxes of each of those chunks, and say the job is done. But it's kind of not done, is it? Because the other half of it is, how do all of those pieces fit together into a whole that works? And so what I've just articulated there is the systems V. It's how you would approach systems engineering within a project. It's not just breaking the project down into its component parts, its work breakdown structure, but it's also understanding how they come together eventually into something that actually works. So systems engineering is of huge value in the context of individual projects. And I think if we are going to be kind of slightly self-critical about ourselves in our industry, we're not always good at seeing how the components fit together into something that works. That integration part of a project is quite often where it goes wrong. And we could dig into some examples of major projects which have had problems with integration. They've had the individual components delivered very well indeed, but that's not enough. How do they come together into the overall output which is delivered? But that language of an output from a project, I think, is really important, because individual projects deliver outputs. Whereas what we actually want, if we believe in that bigger picture that I said of the built environment having a purpose, the purpose being to enable people and nature to flourish together for generations, then we're talking about outcomes. And I think that's even more important, because the outcomes that we want from our built environment will be that we want to live in a healthy and happy place, that we want to have good mobility, that we want security and comfort and all these kind of things that the built environment provides for us. And those don't come from individual projects, they come from the whole system. And so I think it's quite instructive for us to see the difference between the output of projects and the outcomes from the system. And then clearly what the projects do is have some kind of impact on the system, which then hopefully delivers the better outcomes. But this distinction between outputs of projects, outcomes from the system, I think is really important. So now, if we go back to that civil engineer that you talked about on the individual project, I think we can open that civil engineer's eyes to a much bigger view of how they can make a positive difference in the built environment. Because ideally what we should be doing is understanding how that whole system works, intervening more effectively to get better outcomes. And that's something that we're not very good at. Because generally, as an industry, what I think we tend to do is start with the interventions. If we think about what are we going to do to make the built environment better, we instantly jump into solution mode and say, let's do this project here and that project there. What we kind of should do instead is say, what outcome do we want from the built environment? Let's have a proper dialogue about that, involve all the relevant stakeholders, including giving a voice to the voiceless, like speaking up for nature and kind of saying, what outcome do we actually want from our built environment? And then we can work out how the systems of the built environment deliver those outcomes, which then means we can identify within the built environment where the leverage points are, where we can have the most outcome for the least input. Then we've got our projects, which we can deliver in a nice systems engineering-y kind of way. And I think the thing which I'm trying to indicate here is that there's some left to right thinking, which is you do an intervention, it eventually leads up in an outcome, but you are not sure where it's going to go. Then there's right to left thinking, which is starting with the outcome, understanding the system, getting to the intervention. Because effectively, with that right to left thinking, it informs the best interventions. And then the left to right is all about delivery. And as an industry, we kind of need to get better at both of those things. I think at the moment, if we're honest with ourselves, we tend to be focused on the intervention part of the story, and we don't really get the outcome and the system part of the story.
In that context, do you believe that systems thinking should be taught in universities? And if so, why?
Yes, I totally believe it should be taught in universities. And I think that this systems thinking, which is, as I said, it's about recognizing that the whole is more than the sum of the parts. So you don't just focus on the part, you can do both part and whole. I think it becomes incredibly important because we need to see, for example, across sectors. And we could, again, jump into some examples where that cross-sector thinking can deliver additional benefits. But I think that if we end up with engineers who are very focused on a narrow area of expertise, you could kind of describe that as I-shaped. They can get deeper and deeper into a particular area of knowledge. And we need that depth of knowledge. So we should absolutely go there. However, it doesn't mean they can join up very well with other people who've got equally deep knowledge somewhere else. So I think what we really need are T-shaped people who've got that depth of knowledge in a particular area, their area of interest, because it's always best to follow interest, isn't it? But they also have that kind of crossbar of the T, which means that they can connect with others. Because I think it's those connections which then unlock all sorts of other value. And I feel that maybe that's one of the things which we're not so good at in the education. We seem to be good at developing the people who can go deep, but not so good at going across. I think that's not true in all areas of engineering, and I don't want to say the wrong thing here at all, but I think if you look at chemical engineers as a counterexample, in so many ways they're taught to think from the right-hand side of the page, taught to think in terms of outcomes, and so systems thinking comes very naturally. So this is not just an engineering problem. It's not like all engineers think the same way, but it does seem to be that civil engineers are taught to think in these silos, and that can easily be changed. One of the things which I've heard recently, which I kind of ascribe to, is that very often children, people who haven't been into education are naturally systems thinkers. They naturally see how things connect, are joined up. And somebody was saying that education beats the systems thinking out of people. And so in some ways, what we might have to do with education is just not stop people from being systems thinkers. If people are naturally systems thinkers, then we just need to encourage it rather than stop them being systems thinkers through education.
What is your view? What civil engineer should know or might look like in 10 years from now?
That's lovely. So in some ways, I'd like to kind of go back to the history of civil engineering to answer your future question, because there's a lovely plaque on the wall down in the Institution of Civil Engineers, like the home of civil engineering, which has been there for 200 years. This is proper history we're talking about. And that talks about the purpose of civil engineering. And I'll be paraphrasing here, so forgive me for getting it wrong. But basically what it says is that civil engineering is about harnessing the forces of nature for the good of humankind. And I find that inspiring. I think, wow, that's amazing. I want to be a civil engineer if that's what civil engineering is about, harnessing the forces of nature for the good of humans. And I think, yeah, I'm in. Count me in. That's 200 years ago. How can it have then turned into something that seems to be more narrow? And I don't think if we speak to any civil engineers, if there were civil engineers in this room just now, I'm sure they would be objecting to this conversation, saying, no, it's not fair. Don't call us siloed thinkers. That's not fair. But there is something, isn't there, in the way that we treat projects, the way we treat how we see the built environment that is in silos. And I think we have to admit that. So I think if we're going to look forward to that 10 years ahead, what we should be hoping for are civil engineers who have recaptured that sense of bigness, that hugeness of using the forces of nature for the good of humankind, and not being forced into silos, which are kind of concrete or steel silos, or geotechnic silos. And all of those are wonderful things. Concrete and steel and geotechnics are all wonderful things. But if we can see how they come together in order to improve the lot of humans, and I would also say nature in there as well. Let's focus on good outcomes for people and nature. Then I think civil engineering would be in a good place. So I think civil engineering, in many ways, has to kind of reclaim the land that it was always there. We've had 200 years of this, so let's kind of open it up and get excited about the big picture of civil engineering, not the small siloed picture of civil engineering.
Sounds like um, shift in thinking and actually approaching the maybe what we are learning in universities when we are studying for civil engineers, but also what we should do afterwards when we start working, because we are taught that we are working on the projects or which are delivered at a certain point in time at a certain place, and then our next role is next project which is delivered. So there is uh, these boundaries around space and time where we act and where we bring our knowledge. But in reality, what we are looking at is that it is only a smaller piece, and as engineers, we should have awareness and understanding how where it fits and what is the purpose.
Yes, and I think that there's a kind of a lot in what you're asking there, and I think the thing you say about a kind of a mindset shift, I think is really key. It feels like we as an industry need to have a shift in mindset, and that shift in mindset should be towards outcomes rather than just outputs. But in saying this, I don't want to sound critical of what we actually do, because the detail of what civil engineers do, and the detail of the knowledge is still needed. I'm not arguing against that at all. We need people with a deep knowledge and deep capability in all of these areas. They are super important and will continue to be. So I'm not arguing against that. What I am arguing for is that we see beyond the silos and that we can make the connections. And I think that this focus on outcomes rather than just outputs is part of that mindset shift. And I think being able to see the connections is important rather than just seeing the parts. And that is systems thinking. It's about connections and it's about outcomes. And I think that would be a very welcome mindset shift for civil engineering in general.
So, beside the role of civil engineer and having this visibility or understanding of the purpose of its own actions, like working on a certain project which has this purpose in a bigger system and bigger, wider context than just that location and the time when it is constructed or delivered. Um, what would be the role of industry itself in the sense of changing the way the business is delivered? Maybe would it be something to also
Yeah,
important?
I think that this issue of purpose is really important. And so, yes, there's the whole thing of seeing the purpose of the project. It's good to see what the project is for, isn't it? Rather than just seeing the task I've been asked to do in the project and being told to kind of stay in my box. So there's seeing the purpose of the project. And I think part of what I'm arguing for is we don't just see the purpose of the project, but we see the purpose of the system that the project is doing something to, like see the purpose of the whole of the built environment. Because if we see that, and we recognise that we're looking for better outcomes from the whole of the system, then it becomes a bigger job for us collectively to do. So when you ask about what the industry has to do, I think that the industry should really be tasked with getting better outcomes from our built environment rather than just delivering projects more efficiently. Of course, we should deliver projects more efficiently. So the productivity of delivery is super important. And again, I won't argue against that. But maybe more important than the productivity of projects is the performance of the built environment, because that's where we get the outcomes. And I think that in the context of very little money around to invest, it becomes incumbent on us to get more with the money that we've got. And that doesn't just mean that we're more productive on our projects, it means that we get more from the built environment. And we can jump into some examples if you'd like. But I think that that direction of travel is effectively where we have to go on a constrained planet. Because it's not just that we have kind of limited investment to make now, we also live on a finite planet. It means that we need to get more with what we've already got. We need to have that bigger picture view. We can't just see things in a kind of a linear input output type of way. We need to see that bigger picture and understand how we can get better outcomes from what we have.
You mentioned the cross-sectoral approach or cross-sectoral view or knowledge. So how important is for civil engineers to actually know and have connections over different sectors?
I think it's super important. And maybe there's a kind of a question for us as civil engineers to say, so what do we actually want to be? Do we want to be somebody who's a specialist in designing and building some concrete things? Or do we want to see the whole and deliver better outcomes from that? Do we want to be those people who are harnessing the power of nature for the benefit of humankind? Because in some ways they sound like different jobs, don't they? Because if you're just kind of designing and building some concrete things, it's different from delivering those better outcomes. I think civil engineering is both of those things. But if we're accepting this bigger picture, then I think that the cross-sector view becomes essential. And that means that civil engineers shouldn't just be thinking about concrete and steel and geotechnics, structures and geotechnics and these kind of important things. It means that actually we do need to understand how it interfaces with everything else in our infrastructure and built environment. So let me just give you an example. If we're thinking about the need for more data centers, which seems to be happening right now in front of our eyes, then clearly there are civil engineering elements that you would recognize as foundations and building something. There's a building that the data center goes in. But a data center is obviously more than that, isn't it? Because also it's about telecoms. But a data center needs an awful lot of energy. And also a data center needs an awful lot of water for the cooling. And then the water that is used for cooling also has some heat in it, which might be useful somewhere else, in some kind of heat exchange and heating houses or whatever it happens to be. And so we just see in that example of a data center that it's not one thing, it's not one sector, because we talked about the telecom sector and water sector and energy sector kind of coming together in that place. Who has the overview of how things come together in our built environment to deliver the outcomes we want? I think civil engineers can do that. We don't have to just do the foundations for the building it goes on. We could look at another example, which is, again, in infrastructure. It's a very simple one of mobile communication on trains. Wouldn't it be wonderful to have a reliable mobile signal wherever we are on the train network? And so what we have there is a combination of the transport sector and the telecom sector, which kind of come together in doing something that we all want. We could go on, because if we want to have a lot of electric vehicles, which is kind of happening because it looks like the cost of electric vehicles is kind of coming down. So somebody's suggesting that the cost of that will be lower than internal combustion engine vehicles pretty soon. In which case, we could be in a situation where road transport looks almost entirely electric. In which case, is that part of the transport sector or is it part of the energy sector? And if the energy sector is struggling with supply and demand balancing, wouldn't it be good to have some access to 25 million electric vehicles which are going around as kind of mobile batteries? And so you've got this really interesting interface between transport and energy, where maybe one sector's problem is the other one's solution. Because one can imagine it would be a really good way of managing the supply and demand balancing for the energy sector to be able to encourage cars to park up and either to discharge their battery or to charge it up, as part of demand balancing. But then wouldn't it also be possible to imagine that you could encourage cars to park up and charge in order to manage the use of roads? And so, in other words, the supply and demand balancing of the transport infrastructure. And so, in one way, one kind of connection between two sectors, you can potentially solve two sectors' problems, both to do with supply and demand, both where there's never enough at peak, and where if you get that kind of balancing in place that I've pointed to, then you don't need to build quite so much capacity in either of them. You don't need to build new roads. You just ask the cars to park up when there's traffic, peak traffic.
Yes, thank you. That's a really interesting observation, and I think it's something that need to be somehow introduced as the way of thinking and observing challenges or projects. Not necessarily project itself, but maybe the environment in which we as the engineers are operating and doing our jobs.
Yes, absolutely. And I think that ability to see the bigger picture and to be connected, to be part of the connection that solves the bigger problem, seems to be the way that we have to go. And I'm convinced that civil engineers have a huge part to play in that. And I'm sure you're aware that the Institute of Civil Engineers has opened up this new opportunity through infrastructure engineering, which is kind of recognising this connection that civil engineering is not kind of just about the delivery of projects, but it's also seeing that bigger picture and getting more from the infrastructure that we have.
So it's the challenges and the problems of the society in general have to be addressed through systems engineering approach.
I think that's right. I mean, I think putting it maybe as simply as I can, if you got connected challenges, then you need connected solutions, and we simply can't solve the connected challenges with siloed solutions. It just doesn't work. So we've got to think differently. It goes back to what you said earlier about the mindset shift. It means that we need to be able to make the relevant connections.
Now just thinking about it, that some of the challenges that we are facing as a society, like climate change, for example, it seems somehow disconnected from what we have been doing so far as or our role as civil engineers in the society.
Indeed, and I think that would be a really good example of what we talked about earlier, because it would be entirely possible for us to be very busy indeed, doing really good work and using very good technical solutions on our projects, but not addressing the big problem. And so if we've got a climate change, you can have some wonderful projects, but are we actually building climate resilience? And I think that this kind of shows the reason why we've got to take that step back, see the bigger picture, and not just get busy on delivering really important good projects, but see, have we got the built environment that we need in this new context of climate change? And almost certainly the answer is no. Climate change is real, and we need to build climate resilience into our infrastructure and our built environment. And you're not going to see that through the lens of individual projects. The way you'll see it is by taking that big step back, seeing the whole of the built environment, understanding where the vulnerabilities are, and kind of addressing them as a system of systems, and not just in the silos of individual sectors, and definitely not in the silos of individual projects.
What I'm just thinking here as an engineer who is doing, for example, who is working for a contractor and he has a responsibility to manage construction sites. So everyday job is resolving various challenges with people, materials, supply chain, whatever is quality, whatever is there. And in that context, it's really difficult to take that step back and maybe think in a higher level, observing at a higher level, like what can be done there at that moment differently to maybe get closer to that bigger change or shift in the mindset that we are talking about. Um, so um, but if the company, for example, invests in people and start looking into their projects and their delivery differently, that might help also that individual person or engineer to understand its role.
Yes, I think that's right, and you're also correct that by the time you're on site delivering something that has already been designed by somebody else, you don't have so much flexibility to address the bigger picture problem, and you probably aren't in a position to step back and see the big picture. But I think what you would want to know is that what you're doing is helping towards a connected solution rather than just building another thing which has taken no account of what is actually needed, because that would be soul destroying. If you're doing an amazing job on site, but building the wrong thing, that's not great, is it? If you're doing an amazing job on site, building the right thing, because that's what's going to make the overall built environment more resilient, then you can kind of feel really pleased with the work that you're doing. So I think it has to fit into a picture, doesn't it? And the person on site, I think, would want to know that they're part of something that matters and that has purpose, and that is going to lead to good outcomes.
Yes, thank you. I think it's a really good discussion and just trying to also grasp that understanding of what does it mean. I mean, for someone who is working at the engineering level can actually has access to it or is aware, but that zoom out, it's it's something that it's not within the scope. Let's put it that way.
Yeah. I guess you'd be aware of that apocryphal story of the cleaner at the Kennedy Space Center who was asked what he was doing, because it was pretty obvious what he was doing. He was kind of sweeping the floor. That's what he was actually doing. But apparently, when he was asked what he was doing, he said that he was helping to put a man on the moon.
Uh,
And I think that is the kind of thing we're talking about here. That the person on site doing something to the best of their ability needs to know that they're part of a bigger thing that matters. And I think that would just re-emphasize what I was saying, that it's horrible to be part of building the wrong thing. It's wonderful to be part of building the right thing. So even if the individual doesn't have the ability to take that big step back and see the whole picture, you really need somebody to have done that big step back, so that when it comes to what's being designed is designing the right thing, and then what's being built is building the right thing. So I still think that this kind of systems view matters, even if you're a person on the site. You kind of have to trust and believe and hope that the people who do have the ability to take the step back and to do this connected thinking have actually done it. And I think that's probably the area where we need to challenge and to make sure that we are better at doing that in the future.
Thank you. So one of the closings, if I can say, is if you can just finish in your way the sentence "how we build" with three dots.
Yes, I would love it that how we build would enable people and nature to flourish together for generations. I like that expression, and I think that how we build has to do that because that's what we all need. So just to put that simply, if we look at our built environment, it is amazing and complex and interconnected and actually interdependent because transport doesn't work without energy, energy doesn't work without telecoms. So we have got this system of systems, but the way that we run it is in silos, and so that doesn't kind of mix. It doesn't fit. But then also we have this situation where the challenges that we face in the built environment are also very connected. So climate change doesn't happen in silos. You can't solve it in silos. And we could look at all sorts of other connected challenges as well, like moving towards a circular economy or protecting biodiversity, or providing energy security. These are connected challenges. And so what I think that leads us to is to kind of recognize some key connections and some key disconnections. So very connected systems, very connected challenges, but disconnected organizations that run it, and also, I think, disconnected data that they need to run it properly. And so I think that kind of summarizes the overall problems that we need to address. If you look across the whole of the built environment, we need to work out how to address these silos, particularly the institutional and the informational silos. And that's why we need systems thinking.
With this, I would then close this episode, and thank you, Mark, for your time.
And thank you for your time. It's been great.
Thank you for listening. I invite you to share your views, suggest topics, and recommend guests. And now, over to you.